Hi there, I'm Clement. We're starting that series of videos about how to start embedded system development, and we are going to focus for now mostly on C programming and the basics of it. In the last video we just saw how to pack structure in C. Today we're going to have a little bit more of a look about state machine in embedded system, but those can be applied in any type of software development. The concept that we got here is going to be that we want to build some kind of a task that is going to go through different steps, and each of those tasks are going to be independent from each other, and one can be in one state, the other one can be in another state, and we don't really care. There is no communication between them or anything. When we're on a desktop environment, we don't really care about that issue because the operating system is here to manage that for us. You've got different processes or different threads, and they live in their own environment. In embedded system, we don't always have an operating system. When we do, that's great, it's going to handle everything on its own. But when we don't have one, we're going to have to build our own crude version of a scheduler. And for that, you're going to define state machines, one for each task. Typically here, what we're going to do is define a task through a state machine that is going to start by an initialized state, and then is going to immediately go to a state where it's connecting to the Wi-Fi to emulate the delay and the fact that it needs to do stuff. We're going to have to count, and we're going to stay 10 times into that connection Wi-Fi state. We'll see what it means, like that number of times. And then once those 10 times are over, we're gonna end up in a connected status, and then immediately gonna go into a running status where we do our processing, communication, whatever we want. That's an imaginary cases, but that would be typical for an IoT device. For example, connect to the net and then do your main function. If we have a look at the code here, we're gonna see that I'm using an INO file. That's because to do the demonstration, we're gonna use that Node MCU using the Arduino library, as far as it's a very cheap and available board to design with, and you don't need any programmer, just a USB, so that's perfect to try stuff quickly and as a beginner to start playing with. So here we have the structure of a state machine. We got our setup from Arduino that is just going to define our serial communication for us to be able to debug what's happening. We're gonna ignore those two statements for now, and we're gonna immediately go into the loop. The loop function here is the while one that you get in a regular main code. That function contains a switch case, and that switch case that is going to be the core of our state machine. That is one state machine. If you want to build multiple ones for multiple tasks, then you're going to build functions with different switch cases in them. One of the key points for each and every one of the switch cases is that they must not block the processor in any way, shape or form. That is extremely important, because if any statement in the microcontroller blocks the processor, for example waiting for Wi-Fi, then nothing's going to happen anymore. There is no operating system to take back the control over the task that is blocking or anything. So you need to leave the microcontroller flow through its different states. If you need to wait, well then you define a state that is for waiting, like we did in the connecting Wi-Fi here. And if we do a test in it to know if we still need to wait or not, if we still need to wait, then we don't do anything. We don't update anything or what, we just leave. And if we can go forward, then we can update our state. That concept of a state is going to be the variable that we are switching on in the switch case of our state machine. Here it's called current state. That's going to define which state we are currently in. So that one is going to be a variable that is a global variable. In my case, could be different depending on other applications. In that case, for example, we could have put it as a static function inside of our loop function. We got our switch case. We start in initialize state. So for that, we're gonna define our main state as starting in initialize mode. That current state is of a main state type. To make it clearer, to make it less clear, you can define your states as state 0, state 1, state 2, state 3, which is unreadable when you're reading the code afterwards. You have no idea what state 3 means. So in our case, what we got is our current state, that is a main state type, and that type was defined just before as an enum. In that enum, we're gonna list all the possible states that we can have in our application. In that case, as we saw before, we got initialize, connect Wi-Fi, when we are connected to the Wi-Fi, and then running when we are doing our stuff. So we're going to leave those four. No need to define specific values or what. The goal is simply to make it clear for humans reading that, oh, we are in state connected. We are not in state number 2. Number 2, what does it mean? Connected is clear. That's our current state, and then in our state machine, we're going to switch based on current state variable. We start in initialize, where we do our initializing and whatever we want. And then once we are finished with what we got to do in that state, we can update the current state variable to switch to the next state. So there we're going to switch to connect Wi-Fi. And then we break. That means that we're going to quit that switch function, that switch block. And next time we're going to enter the loop, we're going to be able to process the next step. So in that case, we say, oh, I'm in initialize, I do my initializing, I update my state for the next time to be connecting Wi-Fi. So break, I quit the switch, nothing to do else in that function. So we quit. Because the loop function is going to be called again, and we're going to enter our switch again with current state being defined as this time as connecting Wi-Fi. And so in the switch case, we're going to switch to connecting Wi-Fi, and there we're going to start what I talked about, that idea of counter. I hope that's a little bit more clear, that idea of counting the number of times we pass through that state. What we got is our counter, that is a static variable inside of our function. So that static means that it's going to remember the value of it every time we come back. And so we're just going to increase it every time we enter with that ++. And as long as we are less than 10 number of passing through that function, through that state, we're gonna just display, waiting for the Wi-Fi. We do whatever the fuck we want. Once we are done with 10, we do again the same thing of updating the current state variables to go to the next one. And so on and so forth. We go to connected, we exit. Next time when we come back, we're gonna enter in connected state and then in running. The last state that you got is gonna be a forever loop, because it's never gonna update the current state. As long as nobody touches the current state variable, it's not gonna move, and so it's gonna stay in running mode forever. In that case, typically what you would wanna have is some kind of a error detection. For example, oh, we've lost the Wi-Fi for some reason. And so that test of error detection would bring us back to a previous state to connect to the Wi-Fi again, for example. Stop the running and go back to connecting to the Wi-Fi. And once you've done that, it's gonna keep following its regular process. As mentioned before, this can be used as a crude version of an operating system. We got one state machine here in one function, but if we got multiple functions with each their own state machine, we can call them one after the other. It's gonna do what it got to do in each and one of them, and gonna loop back to start working on the first one again. Once again, in that situation, you need to be very careful to not have any one state block the processor, or else it's blocking the entire system for everyone on board. That's it. I hope this helps you clarify your software instead of having like an init block and then many blocks one after the other, to be able to clarify them by using a state machine in your application. That's it. See you. Oh yeah, exterminate dirty code, and yes, be careful. Define good states with good namings. Comment. Put more comments. Yes, of course.